Hello everyone, we are on another bonus lecture and today we are going to do a lecture about the Arduino. Now, there's two kinds of people. Either you know what an Arduino is or you don't know what an Arduino is, and you may have even heard of it but haven't played with it. So this is first just trying to even explain what this is. A lot of people use the name Arduino to refer to both hardware and software and also even a philosophy. So let's kind of clear that up first so that we're all on the same page. A few years ago, I don't know, maybe we'd have to Google it, but maybe 10 years ago, a couple guys from Italy came up with this small little board with a microcontroller on it. And as a matter of fact, we could say Arduino origins or history. And you could take a look at this also. Yeah, right here. So anyway, you can read through this, but the whole idea was a couple guys from Italy, and let's see here, 2003 roughly, and I'm not sure if that's the exact date that it started, but it was a while ago. Anyway, they came up with this kind of project, and the whole idea of the project was to put a microcontroller on it and then make it really easy to experiment, write code, and just play with a microcontroller. Now, the problem with microcontrollers is if you haven't played with one, many of them are fairly complicated. And let me just go back here. We'll just leave it here leave this on Arduino. So a microcontroller is a small computer, right? It's similar to a microprocessor, except a microcontroller has both the processing core and it has all the peripherals and it has the memory built in. So basically it's an entire computer on a chip. That's what a microcontroller is. And microcontrollers have been around for a long, long time. Maybe I'd say probably almost 30 years, definitely 20 years. In any event, before when you would build a computer, say like in the 70s, 80s, you would use maybe a Z80, a 6502. A little bit later, you might use a 68,000 processor. Those were all processors, and to build a computer out of them, you had to add a ROM or maybe an EEPROM for your program, and then maybe some RAM, some peripheral chips to do input, output, and things of that nature. So you had to build a computer around it, and the processor just did that. It just did processing. So it just executed instructions, and it needed support chips to operate. Over time, as our ability to add more and more chips on the same die of a IC, we took all those extraneous extra peripherals and ICs and memory and so forth and just put them on a single chip. And now there are literally thousands of microcontrollers, and there are probably hundreds of vendors, or probably tens of thousands of microcontrollers, and hundreds of vendors that manufacture microcontrollers. Some of the companies are Microchip that make the PIC processors, a line of very small 8 and 16-bit microcontrollers that go from, pennies in high quantities to, a few dollars. Very powerful, actually. There's Atmel, which Microchip actually bought, and Atmel makes the AVAR processors. They also licensed ARM, and ARM, you can get ARM microcontrollers. So when you think of ARM, you might think of processors, microprocessors, but ARM also makes microcontroller cores. So there's a whole ARM series of microcontrollers, the Cortex line, for example. Then there's Freescale and NXP. There are just countless companies that make microcontrollers. And why we like microcontrollers is that they're very easy to work with in as much as electrically we don't have to design that much around them. You basically put the microcontroller on a circuit board, you add power to it, maybe some clocking, some startup circuitry or reset circuit, couple things, and then basically you've got an entire computer. And most microcontroller have GPIOs, general purpose IOs, which then can be used for input or output to drive things, turn things on, control things, read things. And then they have an array of peripherals like serial ports, SPI ports, serial peripheral interface, I2C, which is another serial protocol. They have CAN, control area network for cars, Ethernet, wireless modules built in, anything you want is in a microcontroller now. So they're very, very powerful. And microcontrollers are as powerful as big processors are. So like I said, they're ARM microcontrollers as well. And in the ARM line of microcontrollers, there's the M0, M1, M3, M4, M7 processors or microcontrollers, and these are very powerful. You know, much, much more powerful than, say, a Pentium computer used to be, or even a Pentium 2, maybe even a Pentium 3. Yeah, probably a Pentium 3. The Cortex M7 is faster and more powerful. But even still, electrically, they're easier to work with microcontrollers. The problem is that programming them is not easy usually. You still have to know quite a bit about embedded engineering, and so each one of the manufacturers, whether it's Microchip or whether it's Atmel or NXP or Renaissance or Freescale, you name it, a lot of them will build their own tool, usually typically an assembly language tool or a C++ tool, an IDE, and then you can develop code for their line of microcontrollers, write your code, use maybe some of their libraries, compile it, download the code to the microcontroller, which is usually over a serial interface or a JTAG interface. And JTAG is a special programming interface and debugging interface with just a few pins. And this whole process is still not easy. So even with the tool from the manufacturer that they've either developed or co-developed with a third-party company, it's still not easy. So embedded engineers, whenever they want to build something with a microcontroller, typically they have to, evaluate different microcontrollers, look at their memory, their performance, their costs, all these kind of things. Then they have to learn the tool many times from the manufacturer, or get a third-party tool that maybe supports that microcontroller, but that's only if that microcontroller is very popular. All right, so all of that just makes it really hard for kind of an everyday person that wants to play with electronics, maybe play with these cool things, microcontrollers, to even know where to begin. Even engineers with degrees and that have played with microprocessors in the past, trying to get a microcontroller up and running with a certain tool and so forth is not easy. All right. Therefore, these guys, these couple Italian guys, and other people have done this, right? Other people have made this, simplify this. I have, another company, Parallax has, and lots of people have made products, and some of them just get more popular than others. Anyway, a couple guys, over 10 years ago, came up and said, hey, let's take a little 8-bit processor, not very powerful, and this was the AT-Mega, and I believe at the time it was the 168 processor. So it literally had K of flash memory and maybe, I think, 1K of RAM. We can look it up. Anyway, it's just an 8-bit processor from Atmel Corporation called the AVR, which stands for something I can't remember. Anyway, and they developed this little very simple board that just literally had the microcontroller on it, power, and then a way to interface to it so you could program it, right, over a USB port and over a serial connection. And then the biggest problem, again, so the hardware wasn't that complicated, but the biggest problem is the software. Like, how do you code this thing, right? So getting C compilers up and running is fairly complicated. So what they did was is that they used kind of a version of C, and not really a version. It's just a set of libraries, a set of headers, a philosophy called processing. And this is a kind of a language, and it uses C. And the whole idea is it's designed so that you kind of communicate to a piece of hardware with very simple functions. And so even though you're coding in C, you're kind of using a library and using certain functionalities to make it easy to program. All right, so now that's great, but how do we get this tool to work on all these different computers? So then what they did was they said, all right, Java works on everything right now. So why don't we do this? We'll take all the complicated compiler tools, which is the GCC, the GNU compilers, right? The GNU Foundation, if you ever heard of that, it's a set of free tools, all kinds of technology. And one of those tools is the GCC compiler, which is actually an acronym of itself. It's the GNU GNU compiler something, which is the GNU compiler something. Anyway, so GNU makes a thing called GCC, which is a compiler, and these compiler tools work on many, many microcontrollers and microprocessors. So they have a version or a core piece of software for many, many, many different targets. All right, one of those targets is the AVAR. All right, so the two guys, the Italian guys said, all right, let's make a Java tool that is super simple, not really complicated. All right, and if you're a programmer, you use Visual C++, big tools like that, or maybe you use Xcode, and these tools are massive, right? But when you're learning a program, they're really overwhelming. There's just 10,000 menus and settings, and you don't know even where to begin. So they said, people cannot know anything about this. We just want something that's like a text editor, and you literally press a couple buttons, and it will work. And it'll work no matter if you're on a Mac or Linux or a PC. All right, so that's a challenge. So here's the deal. We have to have this Java tool, which will work on all these computers and always have the same look and feel. Under that, hidden, is the GNU compiler. GCC is running, and they've set it all up to run and actually take your C code that you're going to write inside of the editor, compile it, link it, build a binary, have some piece of software that can download it to this little board, which is shown in this little picture right here, and then do whatever it is you told it to do. All right, so that is what Arduino is. So Arduino is, initially it was a very specific board, the Arduino Uno, which had the Atmel AVR chip on there, the 168, and they all have an Italian name, so it's kind of hard to keep track of all this stuff. But anyway, and then after they came out with kind of another version, just kind of upgrading it, and then it kind of exploded and everybody got into it, and now there are Arduino pieces of hardware that are based on many, many different kinds of microcontrollers. But the philosophy is, the tool that they made, you can still use it to build a program for any of these Arduinos, and the libraries all have layers of interface. So if you say like you want to write a pin or read a pin, it's always write pin and read pin. So it's always the same. And then there's a layer of software that interfaces to the lower functions of the API of that particular microcontroller, whether it's an ARM controller or an AVAR or a PIC or this or that, it'll always work. So the point is, Arduino is not just a board. Arduino is not just a piece of software. Arduino is an entire philosophy where they're like, we're going to build a board, we're going to build a tool, we're going to build an interface, we're going to build it on top of this language kind of specification based on C and C++ called processing, but it's really just C and C++, so that anyone can write a simple program with just a few lines of code, not know anything about microcontrollers, and magically the initialization code that we developed, the Arduino guys, will start this microcontroller up, whichever one it is. It'll take care of all the initializations, the timers, the peripherals, the this, the that, the Ethernet, all the complicated things, so that just within a couple lines of code you can say, do something. That's what Arduino is, and that's why it got so popular, and now it's a very, very popular platform for hobbyists. All right, so now professional embedded engineers like myself, we rarely will use an Arduino for anything because we're talking through layers of software. The tool is very primitive and simplistic. The performance is very low because of all this layering. But for someone that's not doing high performance computing and needs to build low-level to-the-metal hardware and software, it's a great way to build things to do things. All right, so that's what we're talking about. All right, now, I know there's a lot to this, and I just want to make sure that, because a lot of people they don't even know what's kind of the whole Arduino story. Now, let's go even farther. So the two guys that did this, which I can't remember their names, that's right here someplace. I'm not even going to look for it. You guys can, because it's going to be a long lecture, another one of my long lectures. But anyway, the two Italian guys were like, we're doing great, I love you, you love me, and then, but one guy is the hardware guy, and the other guy is a software guy, and they got into a fight, right? Probably a fist fight. I don't know, maybe they did. But anyway, this happened a few years ago, probably, I don't know, 3 years ago, something like that, 4 years, no, maybe 3 years ago. They got into a fight. The hardware guy's like, no, we need to focus on making more advanced hardware. And the software guy's like, no, we need to make better software. So they got in a fight, and like literally they split the company in half. Then what happened was they went to court, And the judge said, you are destroying this platform, this ecosystem, all your customers, and this and that. This is ridiculous because someone bought an Arduino and now it's not going to work with the other Arduino. So they even had two websites, like Arduino. And this is where I can't remember exactly, but you can read about it. There was Arduino.org and Arduino.com, I believe. That's what they split into. And so customers would go to Arduino.com and think that they're Arduino.org, or they'd go to Arduino.org, but they thought they were at Arduino.com. And they even had two versions of the IDE, the Integrated Development Environment, which I'll talk about what that is also. That's like the thing that we talked about where you program. So these guys are fighting. The judge finally said, you know what, stop this. This is ridiculous. I'm forcing you to remerge the company. So this happened about a year ago, I think, or so, maybe a year and a half ago. They remerged the company, and now there's Arduino.cc, right? Another one of these domain names. Anyway, so now when you go there, it's one company again, and everything's hunky-dory. But it could be confusing to you if you look back and things from the past, you'll get confused. So check it out. So if I go to Arduino, let's go to Arduino.org. It says Arduino, but check this out. You're now going to be redirected to Arduino.cc. All right. And we'll give it 5, 4, 3, 2, 1. That's the longest redirect. Okay, there it goes. Now check it out. If I go to Arduino.com, if we go to Arduino.com, it's a resolving host. So, well, that's interesting right now. Okay, so I'm going to tell you right now, I can't believe someone doesn't own that. That's interesting. Huh. Okay, so that's a good little website to grab that domain, and I bet you somebody already has that. But anyway, that was the other one, I think. And then no matter what, now you need to go to Arduino.cc. Okay. So, but I just wanted everyone to know this because, you know, I like the history of things, and it's kind of interesting to see what kind of goes on. And this caused a big upheaval because everyone's like, is Arduino going to be around? And should we keep messing with the software and building things with it, or should we just like throw it away, right? Okay. Now check it out. It gets even more crazy. So remember I told you there's lots of different Arduino hardware now that's kind of Arduino compatible. All right, so let's see. If we go to, I believe, I think if we go to Buy Arduino, yeah. All right, so there's all these different, t-shirts really shouldn't be in here, but if we go to, I think if we go to Arduino, yeah, boards and modules. All right, shields are things that plug into Arduinos. All right, so we'll go to boards and modules, and then you can look through here and you can see all the different Arduinos that there are. And like I said, there's all these different variants now and versions, right? Because it started off with this one. So this Uno right here that when I hover it does this, which I don't like. So let's actually, there we go. All right, so this is the very first one. Now, this version here isn't the first one, right? This is Rev 3. So over the years, this has been updated and updated. It still uses the same processor, though. This ATmega 328P is a very, very, very simple 8-bit processor. And I believe it has 16K of flash. It's 8-bit, 16K of flash, and I believe 2K of RAM or 1K of RAM. Let's see. It has 32K of flash, and then 2K of SRAM, and then 1K of EEPROM. So this is very, very limited, right? But this is with this microcontroller, you can do a lot with this, and clock speed is 16 megahertz. I'll tell you that you can definitely clock these things up to almost 30 megahertz if you actually want to. All right. And then if you go here and click the data sheet, right? Let's just real quick, let's go click this data sheet. You guys know how to read data sheets if you went through the class already. If not, this might, all right. And so what's interesting right now is, remember I said Microchip bought Atmel? Microchip bought Atmel. And because of that, Microchip is a massive corporation. Atmel was a massive corporation, billion-dollar corporation. A lot of the website is still broken. So if we just type in, we're just going to type in ATmega 328P, and then we'll just put datasheet. All right. All right, we'll go here and see, this is on SparkFun, so this is on their local server, right? All right, so anyway, you read through here and you can see there's variants of this thing, and then here's the original one was the 168 that they use on the Arduino, and then now they're using the 328P. And then you can kind of go through here and look at it. So 20 MIPS of processing at 20 megahertz. It has a multiply, which is rare on little 8-bit microcontrollers. To have a multiplier, having a divider is even more rare. And then it talks about all the different peripherals, right? It's got 8-bit counters, 16-bit counters, it's got a real-time counter, PWM channels, pulse width modulation, ADC, analog digital converter, temperature measurement, it's got UARTs, it's got a SPI interface, it's got I2C compatible in the SPI interface, which is good. Lots of power features for sleeping and low power, and then different voltages that it can be ran at, and speed grades and all that. Anyway, obviously if you're going to work with this, you're going to read this 452-page data sheet, and I've read this and many, many others, hundreds and hundreds of data sheets, but I've read this cover to cover before, all right? And it wouldn't hurt you to read it. But you don't need to. You can use this with the Arduino Philosophy tool, all that, and not know anything about it really, just other than it's a black box. All right, so the whole idea is we can buy this one here, all right, and now there's knockoffs and clones. So there's legal and illegal knockoffs and clones, right? So that's another thing. And a lot of people, one of the things about Arduino is it's open hardware, so you can copy it and you can even sell it, right? But you just can't call it Arduino. If you want to call something Arduino, you have to contact the Arduino guys and say, hey, can I call this an Arduino blank? And usually they'll say, hey, sure, bro. So you can do that. Anyway, so there's the first one. And then you can see there's all these other ones. This one has Wi-Fi. This one has another, it has a module and a processor in it. Here's another one, This one's using another Atmel chip, the Mega 2560, which is more powerful. Little Arduino Nano. This one right here, as a matter of fact, this is the one that we based what did we do? We did the Simon game in the course, or you will if you haven't seen it yet when we do PCB stuff. And the design of just the Arduino Nano core, just this stuff right here, is what I used so that it would be compatible with Arduino when I made the little Simon game. And then I put a bunch of other stuff around it, right? But if you want something in this format, right, you can use it. But if you look at the tech specs, check it out. It uses the same AT Mega 328 processor, 8-bit processor, all right? Okay, so the whole idea, if you go through here, you can see they have a lot of versions that are Arduino. And all that really means is some of them are faster, slower, some are based on ARM, some are based on different processors, some are even based on Intel processors, or at least used to be. And yeah, like this one, I think this one's an Intel module, as a matter of fact. All kinds of crazy stuff. And there was even more when this war was going on, because the hardware Italian guy wanted way more. It's like, I just want tons and tons and tons of options for people. And then the other guy's like, no, it's too complicated. You're confusing everybody. Anyway, so whichever one of these you get, no matter which one you get, you can program it with the Arduino tool. And if you want to do simple things, it's always very, very similar. Now, obviously, an Arduino that doesn't have wireless can't do wireless things, right? So, like this Arduino, basically is an 8-bit microcontroller with GPIOs and a few peripherals. So if you want to blink LEDs, do serial communications, control motors, that's the one that you can use that'll do that. If you want to do wireless or Bluetooth, you're going to need one with wireless and Bluetooth features. If you try to run code for wireless and Bluetooth on this one, it's obviously not going to work because it doesn't have those features. So again, these interfaces insulate you from programming all that stuff. It's very simple lines of code, but the hardware has to support it. Okay, now, that all said, we can use one of these, but a lot of different companies create microcontrollers and other devices, and then what they do is they want people to use them. Hobbyists to start using them, as well as professional embedded engineers. So what they'll do is either the company itself or just individuals that are just like, I'd like to use this with the Arduino tool, will port the Arduino tool or create support or a plugin so that the Arduino tool will recognize and be able to use that other piece of hardware. So basically you make it Arduino compatible with software so that you can write an Arduino program to blink an LED, take that same program, run it on here, take the exact same program and run it on some other piece of hardware because they've made it compatible by adding software and creating the necessary files and so forth so that the Arduino tool itself can understand and build an executable for it. You're going to understand all this more as we go if this is all sounding crazy right now. Okay. All right. So what do we want to do? So I want to show you what we're going to use. So what we're going to use is there's a new wireless module called the ESP8266, and its big brother, the ESP32. The 8266 came out a couple years ago, and the ESP32 came out about a year ago. These are price-wise, performance-wise, really almost an order of magnitude cheaper and better than anything you can get. They're Chinese made, and they're just so much better than anything else you can get from other vendors that cost just a lot more and are way more complicated to run. So the Chinese company called ExpressIF, which I think I have here, yeah, ExpressIF, and this company developed this, and they develop these other kinds of chips. So they developed the chip, and so I'm going to focus on the ESP32, the 32-bit version. So if you kind of go here to products, and you'll see they have these this big line of things right here. So here is the ESP32, and then there's some development kits and all that. So let's just talk about the ESP SoCs. We'll go here. All right, and the website is just expressif.com, and then it kind of explains, you know, what these things have. Now, so basically you can get these kind of chips, right, this ESP32 chip, and with very few parts, you can build an entire wireless Bluetooth transceiver with very few parts that's very small and very cheap. These things are like $1 a piece. They're crazy cheap and crazy powerful. So they have dual core processors. And just to give you a rundown of kind of the hardware, they're not ARM based, which is interesting. They're Extensa processors, 32-bit. They run up to 240 megahertz each, 2 of these cores, plus a third processor, the ultra low power processor that's on these chips. They have internal RAM here, 520 kilobytes SRAM, and then, you know, roughly the same of ROM, and then, you know, 16 kilobytes SRAM. And this is not actually real-time clock. I forget what this is called, but it is not real-time clock. I forget what that's called. Anyway, but you can see they have a lot of RAM and a lot of ROM. Then they add on a external flash and possibly an external RAM called PSRAM, and so that you can have 4 or 8 megabytes of flash, and then you can have 4 or 8 megabytes of RAM also. Then they have all these different names. Now I'm gonna apologize right now. The Chinese have crazy naming, and it drives me super nuts. And it's very hard to figure out what all these different things mean. So what you kind of have to do is go to Wikipedia, and here's like the ESP8266. And this is not too bad, right? If you read through here and you kind of look at this and you see all these kind of crazy names, the Vroom, and just ridiculous names. And then there's ESP1 and the 2 and the 3 and the 4 and the 5 and this and that, and which ones have FCC and which one's this and which one that. And then it's like, well, wait a minute, ExpressIF makes the chip. Do they make the module? Yeah, they do. And then there's another company, AI Thinker, that takes the chip and makes a module. Then there's other companies, and all these different companies actually make things with them, right? All right, so you got to kind of read through this, and it's crazy making. I'll agree. Then you go to the ESP32 on the Wikipedia, and again, same kind of thing. Shows you the architecture. Read through all this. All right. Then once you get down here, you kind of read all the different variants of it, right? So the variant that we are interested in is down here, and it's called the Rover B. Yeah, I know, Rover, Rover. I don't even know where they came up with this. And there's 2 variants of it. One is called the one is called the B. The B is the newest version, and then there's the IB. The IB just means that it has the antenna socket on it also, a little micro antenna socket. So if you want that, it's called a U.FL connector, tiny little micro connector for antennas, but it has a built-in trace antenna also. The reason why we like this is it's the newest ESP32 chip built into a module, and it supports the external RAM to add more RAM. So we like that 4, 8 megabytes of this PSRAM, it's called, all right, which is pseudo-static RAM. Okay, so this is what we want. So we want something that has this module, the ESP Rover B module on it, okay? All right, and then like I said, there's other companies that then make things with the chips or the modules, and they sell them. So it's very confusing, all right? Okay. Now, so check it out. So then we go to a place like Mouser, and then we type in ESP32 Rover, right? All right, and then we see there's all these different modules. All right, and look how cheap they are, $4. So this is just the module, and the module has, let me make it larger so you can see it. Oh, that really helped. Not. Let me see if that helps. A little bit. It's got these castellated pins, so you could just put this on a board and it's completely self-contained and done. You look at the back of it, Here are the pinouts, right? Here's ground, power, and all the IOs. It's a complete system on a module. You don't have to do anything. But it's to program it and stuff, you need to add a couple little things, and to power it, obviously, you need to do that. So then people will then take these and put these on kind of carrier boards to help you out a little bit, right? Okay, so see what that's all about. So if you scroll through here and look at some of these products, you can see here are some big boards that have the module on there. So check out like this, for example. So there's one of these with a Rover. It's called the ESP Rover Kit. And again, don't blame me about the names. I didn't invent all this. So you can see here's this kit, and it's just got a few extra things on here, some switches, some things like that, some headers. There's the module. On the other side, or I believe it's on the same side, not sure, because I don't have one of these. This one's got an LCD, so you can do things with LCDs, right? Okay. Now that right there, what is that, 50 bucks, 40 bucks? Super cheap for what you get, all right? But you go a little farther, now here's what we're talking about. So now here, this one's the Rover B, and then this one is the Rover IB, which has the antenna on there. Okay, so let's just look at this one. And again, all these crazy names. So the manufacturer, Expressive, actually makes these, and they call these the ESP32 Dev Kit C-VB, all right? I know, crazy, huh? All right, so that's what it looks like. So the module has just been mounted on this little carrier board that's a DIP board, dual inline package, so that you can plug it into like a solderless breadboard or maybe another board to experiment with it. And here's a micro USB. Now, obviously, if you were building something, you wouldn't want this carrier. You would just want the module because you would have all this other extraneous stuff. But there's not much. Here's a power supply. There's a regulator. There's a couple transistors for booting it and flashing the memory. And then this right here is a USB to serial bridge, typically a FTDI chip or a Silicon Labs CP2100, 2200 series USB UART, and then a couple little switches, couple LEDs, and that's really it. So really just a couple little things to talk to the thing from your PC, Linux, Mac, and then the pins are just pushed right out to these headers, which are just, if you look here, they're just standard pins to go into a solderless breadboard. That's what we want. So we want this right here, right? Okay, so you could buy this right here off of Mouser or DigiKey or someone similar that you can get access to, right? Or you can get it off Amazon, or if you're, depending on what country you're in, Banggood or Alibaba or Made in China. There's lots of different places, but we want something that looks like this, and it has the Rover B or IB with the extra little antenna connector on it, because we want kind of the latest chip with the external RAM. All right, so I know this is all crazy. Okay, so now if you go to Amazon, and I like showing Amazon because mostly the whole world can get to Amazon, and it's easy to show examples. Okay, so if I type in ESP32 Rover into Amazon, a bunch of these things come up, and there's all these different companies that basically take the module and make a little carrier board, and this isn't the same one we just looked at on Mouser. These are all kinds of, like, this is high let go, and this is just this is Geekworm right here. This one's actually from Expressive, the manufacturer. You just kind of go through here, and the Expressive. Some are made from Expressive, some are made by different companies. Okay, the one we want, well, not the one we want, but the one I'm going to use in this demo that, we have maybe a half hour or more, is the Rover B module mounted on a board from Geekworm. And this is what we're going to use, but now we're looking for the one that's mounted on a board, which is down here someplace, I believe, or it's up here someplace. Let's see here. I think it's this one. Yeah. And yes, it is this one. Okay, so, oh yeah, there you go. You purchased this item on November 14th. Good, thanks for that. So this is, and I could have got the ones off Mouser, but when I went to go try and order those on that day, they didn't have them. They ran out of stock that fast. So I said, okay, I'll just find something similar and then try and find this. Okay, so here it is right here. Now the cool thing is that the Arduino tool not only will let you program this, but it understands it. The only difference is that when someone makes one of these, when they run the pins out from the module, they typically run them out, pretty much out to each one of these pins, but they might put a power here, they might put this here. So the pins are slightly different. So you need to pay attention between manufacturers of these boards, Geekworm, Expressif, Adafruit, SparkFun, High Let Go, you name it, where the pins are. So you got to kind of look up. So on this one right here, I can see all these I/O pins. This is what goes on these pin headers. This is this pin header, and this pin header is this pin header, and this pin header. So you can see it's ground, B sub DD, IO34, blah, 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 blah. Then there's a couple peripherals on here, LEDs. Where are those LEDs? If you look right here, and I know it's hard to see, but the two LEDs are connected to IO27 and IO0. So if I somehow can talk to IO27 and 0, I can turn on the onboard LEDs, which is right here and right here, so I don't have to hook anything up. Otherwise, I can use all these IOs to do whatever I want. All right, now, okay, so the first thing that we got to get is we have to get one of these ESP Rover B, and you don't have to use that. You can use any ESP32 you really want, but I prefer if you use the Rover B because it'll be similar to what we're doing, and then it's, they're all the same cost, so I mean, you might as well get the latest, newest one. And this one has 4 megabytes of this extra RAM. All right, now, and then here's the pinout of it right there, which I already downloaded and copied onto my computer. Okay, now, all right, we're getting there. We're getting there. I want you to see everything. Okay, now, so, oops, you want to learn about the ESP. So you can go onto those websites, right? You can go to the, and I want to show you this, but you can go on to the Wikipedia page, right? And here we go. Here's an ESP32. So if you just go to Wikipedia ESP32, then you can read through here, all right? Which I suggest you kind of do, kind of peruse this, all right? Then you also go to the Expressif site here, and you can go here and kind of read their stuff, and all their documentation and support is in here. Now again, this is if you want to program it kind of natively and then really understand what's going on inside of there. But if you don't really care, you don't really need to do this, but I suggest you do, because if you're like me, you like to know how everything works from the atoms up. Okay, then there's another website, which is ESP, I'm going to find it for you. Yeah, ESP32.net. This is a really, really good website. This is like this big list of everything you could need. So if you really are into wireless and IoT, and you want to try out the Arduino and the ESP32, I highly recommend you read this page and scroll through it, like all the documentation, and there's tens of thousands of pages of stuff here, but it's got every piece of information you want, all right? And you can kind of go through here and see all these examples and this and that and development. And then there's what's down here, hardware, explaining to you. And this will really, really help you. This is really interesting and educational, so I really suggest you do this. It takes about a night or two or a weekend, but it's definitely worth it. You can see it just goes on and on. And this is just all the links. Then imagine going to all the links, right? All right, so I've done that, and at least once, and now, I've purged it out of my memory, but I did it so I know. Okay, after you go through this, there's a lot of different documents that you might want to read. One of them, so there's no book on the ESP32 from Expressif. They have documentation, which they've written, which is actually pretty good for Chinese documentation. I'm quite shocked, actually. But there's no like books on this. There's not anything big. If you go to Amazon, look for ESP32 books. I think there's one now maybe, and it's basically a copy of the documentation. Not very good. So there's this dude, this guy, and his name is Colbon. I forget his first name. He's actually from Texas, right? And I live here in Austin, Texas. He's from Texas. I haven't talked to him. But he started with the ESP8266, and then he read about it and figured it out and wrote a book about it called the ESP8266 book. Then he did the same thing with the ESP32, and it's totally free. This book is free, and if you just Google for it, Colbon's book on ESP32, you can get it off. I forget where it is. It's on one of these free booksellers that you can either give them money or give them nothing, and then just download the PDF. Neil Colbon, that's right. And anyway, so this covers the ESP32. I've read this entire thing, and the ESP8266 version that he wrote is much, much better. This one definitely needs work, and it reads, it's just like stream of consciousness. So let me get down to some of the actual text. All right, so there's Neil in Texas, and he starts talking. So the first few pages are pretty good. It's like showing you the pinouts of things, and this is important too. All these different kits that we're talking about, the Vroom and the this and the Dev kit, and then showing with this kit, here's kind of the pinout. But remember, with you might have a slightly different module. Here's the module, but then it's mounted a little bit different, so these GPIOs might be a little bit different. But a lot of times these numbers are always the same. So GPIO 36, depending on where they routed it out, is also ADC channel 0. So the multiple functions is the same because this is all from kind of a hardware perspective. So it's always the same. All right. And then there's the kit I just showed you, the schematics. All this stuff is all open. There's the Rover Kit we just talked about. And then all these different things explain how you communicate with them serially and this and that. So this is not bad. This really saves you a lot of time. Then what he does is he shows how to program with it with what's called the IDF, the IoT Development Framework from ExpressIF. This is a C++ library designed to be compiled with like GCC directly, or maybe you could do it with CLang, the other compiler, and forget about Arduino. That's for like, you're kind of a hardcore embedded guy or a Linux guy and you really like doing things with a command line. This will explain how to do it, and it's not easy setting it up, and he had to figure this out and get it all working, but he did, and he shows it, and you can do that. If you're really into Pain and Linux, I would give this a try. But if you just want to start playing with this thing, don't. But again, it doesn't hurt to just peruse through this, and then after a while, it turns into just basically a giant dump of the API that ExpressIF created with this IDF, IoT Development Framework, which gets boring. But thankfully, there is a index over here where you can kind of go to different things and see compiling code, building, audio, blah, 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 and kind of read about these different things. So this book right here is the best and only book, even though I really don't like it that much compared to his previous book, because this one just feels not done, rushed, could have been better, I don't know. And then, of course, here's the Rover data sheet, which you get from the vendor. All right, this is a pretty good data sheet, and it's not too long. It's only 26 pages, so just read this. I would advise you read this so that you kind of know what's going on. ESP32 Rover. You always read the data sheet. This is just about Bluetooth. This is something I'm interested in, the ESP32 Bluetooth architecture. Again, it's pretty short, just kind of talking about how the Bluetooth works on the chip. Okay, then what's this thing here? This is the ESP chip data sheet, not the Rover, which is the module with the chip. This is the chip, and so this is kind of talking about the chip, a data sheet, just electrically, very high level. Now here's the nasty technical reference. This is where things get ugly. So here is the ESP32 technical reference. Again, I've read this, and this talks about the programmer's model. It's 666 pages, the perfect number to put for anything. And so read through this if you want. You don't have to, again, you don't have to read any of this stuff, but I'm saying if you really want to know, I would read it. And then whenever, and people always ask me, Andre, how do you build computers? How do you design single board computers? How do you, build an ARM computer? This is how I do it. I read everything. Then I read what's called the hardware design guidelines. This is for hardware engineers. How do you build something? So I got to read this, and it's only 29 pages, pretty short. This typically shows us how to power it up, how to do reset, how to sequence the power systems, how to maybe connect antennas. There's reference schematics, and gives us something to start with so we don't have to do everything ourselves and figure it all out, right? Very, very short, actually, and then maybe a possible layout and all that kind of stuff. Anyway, that is the hardware design. So these are all the things that a hardware engineer will read end to end, cover to cover, if I want to build something and program it hardcore and really, really know what I'm doing. For you guys, if you don't care about it, you don't need to do any of that. I might read maybe the Rover data sheet, the 29-page thing, right? And I think that's it. Yeah, so that's it. So those are just some things. You can get them all from ExpressIF. Okay, now, all right. And again, I didn't even know what's going to happen with this, right? I really need a lot of time to do this, because this is really a whole course, and I'm just trying to do it in one lecture. So I'm going to tell you one thing I'm going to do. I think I'm going to make this into like 3 lectures, where we're going to try and get some stuff done this time, and then I'm going to do a couple more lectures. We're still going to use the ESP and do some more advanced things. So let's just see how far I can get. Okay, what are we doing? All right, so we want to program this with the Arduino tool. All right, I'm a Windows person, so I will use Windows. If you have a Mac or Linux, it's very similar. and there's a million tutorials online that can show you. So step one, let's go get the Arduino tool, which unfortunately I already have. But how would we do that? We would just go to Arduino, go to software. Now they also have a new online tool which works from your web browser. I don't like anything online, so I like the real download. So you go to downloads, all right, and then we download the Arduino IDE. So it's up to version 1.87. All right, and then you can see you got the Windows installer, the Windows zip, the Windows app, and then Mac OS, and then Linux, all the different variants of it. All right, so download whichever one you want. All right, and then and simply install it. All right, and I'm just going to assume that you can do that. All right, now once you've installed it, now we need to do a couple things so that it understands the new ESP32. When you install the tool, so after you get done installing it, let's look here at my desktop and try and find any semblance of anything. All right, here we go. So here is the Arduino tool, and it'll create an icon like this infinity icon. And then if you go and launch it, let's go do that, double click. And then this will come up. All right. This actually is not the fastest thing in the world. I almost think like it's just sitting there purposely. All right, and forget this right here for now. Forget this right here for now. What's inside? Let's just pretend that's blank. It just loads the previous thing that I was working on. This is the Arduino IDE. So if you're used to Visual C++ or Xcode or even Eclipse, you're like, wow, that's super simple. It is super simple. And because it's so simple, you can't do a lot with it. You can basically compile and download, and that's it. You can't debug, you can't do anything. All right, that's it. Very, very simple. All right, and then as a matter of fact, let me just open up something real simple here. And every time, and another thing is, as far as I know, you cannot, there's no tabbing at all. It literally opens up another window and that's life, right? Very crude, but a lot of people like this and they're fine with it, so whatever. Okay, here's like a little Blink program, and we're going to get to that in a minute. Okay, let's go through kind of all of the things here. So obviously I can click that and make this bigger if I want, all right? So we can do that. Let's, as a matter of fact, let's do that. All right, so you go to File, and we've just got the standard things up here, open, recent, and then we have this thing called the sketchbook, all right? And the sketchbook is basically a directory on the computer with your programs. Now, normally, if you were in a big IDE, a big professional one, these would be your projects or your workspaces. They would have tons and tons of files for each thing, right? There'd be a gazillion files. In Arduino universe, there's not. There's like one file, your C file, and then if you need any other libraries or header files, maybe you put those in there if you understand what those things are, if you're that advanced. But if not, it's like literally a C file. Then all the other stuff, the tool brings in to build it. So it really, really, really simplifies this, okay? Then there's a thing called examples. This is interesting. What this is a list of everything that people have contributed, whatever, and there's all kinds of crazy stuff. And depending on what you've got loaded or not, you'll see more or less of these things. So for example, up top, there's 1, 2, 3, 4, up to like 11 here, right? And then there's examples for any board. Then there's examples for the ESP32. Now, the only reason we're seeing these is because I installed this, right? But if we go to built-in examples like basics and we say blink here, what'll happen is it's going to open up another window. Check this out. There's our other window, and we can close this one now, which drives me insane. And then here is the blink program. That's it. So now, if we look at this program, there's setup and loop. Now, if you're a C++ programmer, what's really going on here, the main in C++ is somewhere else, and then the main first calls setup here. And again, there's one thing I have to assume is that you know how to program in C or C++ a little bit. If you don't, you're going to be completely bewildered. But if you're okay to follow this, I think you can still get a lot from it. And then after setup is called, main just calls this loop, and then you can sit inside this loop. This loop function keeps getting called inside of main, excuse me. The loop function keeps getting called inside of main with a infinite while. And then also in that infinite while, there's a couple calls to some interrupt stuff and this and that, because the system may have to process other things. So This, you don't want to stay in here and put an infinite while. You can, but you'll break stuff, anything else that needs to operate asynchronously. So for those of you that are C++ programmers, you put everything in this little loop, kind of like silly, and then just make sure you exit out of here and it'll come back really quick after it does a couple little things, and then you get control back again. All right, but don't stay in here. Don't block in this function. All right, you'll break some things. All right, so we see we have this little tiny program here, and if you look at it, it has this one thing that just says pin mode, LED built-in output. All right. And then it has loop, digital write, LED built-in high, delay 1000, digital write, LED built-in low, delay 1000. So all this thing does is it turns one of the GPIO pins into an output mode, and this is defined elsewhere. This LED built-in is defined elsewhere, and it's one of these. It's just a number, and in Arduino, each one of the GPIOs has a number, and it's setting it to an output, and then we just drop into this next function, which then just basically asserts a high. It delays 1000, and wait for a second. Each one of these is a millisecond, I believe. And again, with Arduino, you have to look up these APIs and make sure what you think they're doing and all that, and you can do that on the Arduino site. Anyway, digital write, then it writes a low, and then it delays again. So basically, it's going to blink an LED. That's what that would do, right? And we're going to play with that, all right? And then you can go read about it right here. Okay, now let's keep looking. What else is here? So that's what all the examples are. And then close, open, save, and then preferences. Now this is important. Okay. First, network settings here, if you want to mess around with anything that's advanced stuff for proxies and all that, you don't really need to worry about that. What you do need to worry about is this. So sketchbook location. So you see in my computer, D development, NTV projects, ESP32 sketches. So I know where this stuff is going, right? So just put yours on C or D dev or whatever, wherever you like to put things, and create a directory. Typically, I just call it ESP or whatever the project processor is, and then sketches, and then it'll dump everything inside here. Then there's just some editor stuff, some things like this, verify code after upload, etc., 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 etc. Just some optimization things. You can play around with these, check for updates on startup, all that kind of stuff. Then this is important. All right. This is where you go to find additional boards. So when this thing loads up, you are not going to have ESP8266 or ESP32. The only way you're going to get these extra packages is someone's got to give these things to you. They have to be in a format that this tool, Arduino, understands, can parse, and bring all in. And there's a whole series of tutorials and documentation on if you're a vendor and you have your own microcontroller, your own project, your own whatever, and you want Arduino to be compatible with it, you have to build a file, which is a zip file, etc., that has a bunch of other files and INI files and JSON files and XML files, all kinds of stuff that describe everything and then contains everything, all the library files for the particular processor. Given that, that's what this is all about here. So for the ESP8266, here it is here. This is the ESP8266. All right, and then if you look at it, it says http arduino.esp8266.com/stable/package underscore ESP8266com_index.json. Okay, I will put this in the documentation, and then, but that is not important. We're going to put that because we want that also just in case. But here's the important one. This is the 32-bit ESP. So this one is https://dl.expressif. So this is coming right from the expressif site, .com/dl package underscore ESP32 underscore index.json. This bad boy is the one that's important. So you have to add this to this preferences under the additional boards, okay? When you do that and click OK, cool. Now, it may need a restart to be able to find this, so we're just going to restart this just in case. And this is not like this hardened, awesome tool. It is a Java program, and it is buggy, and it is slow and all that. But you know what? Millions of people use it, and they get around it, so I mean, whatever. Okay, now, so now here we go. So we already did that in preferences, and it's sitting there. That's cool. All right, now what we need to do is we need to go to Tools, and there's a number of things we're going to do here. But one of those things is, and the order we do things in can change, but we're going to go to board here, and it's saying what the board is right now. I don't really like this. Pretend it doesn't. It says the wrong board. All we want to get to is this thing called Board Manager. We double click that, and then it shows all the different boards installed. All right, so what we do is when you first install this, I want you to type in ESP32. All right, once you do that, then boom, here it is. Here's the ESP32 stuff it just found, which is going to give you all the ESP32 libraries, examples, sketches, and all that. It's already installed, so I don't need to install it. If it wasn't, it would say install here or install here, and then I would install it and then say close. So it's already installed. Now I'm going to say close. Cool. Okay. Now, what's the next thing? So when I go here, now it says pick your, so now the whole idea is we're going to pick our actual product that we have. So I have the ESP Rover B module, right? I don't have the Rover, I have the Rover B. Now the good thing about these Arduino things is a lot of times, even if you don't have the exact one, close enough is close enough. So now, if you hadn't done what we just did, you wouldn't even have any of this stuff down here. All this stuff just populated after we put in that information. And you scroll down, and these are all the different companies that are listed now because of that installation. All right, and there's hundreds of these boards, so obviously they're not all here. All right, but here's one right here, ESP32 Rover module. I have the Rover B, which just has more RAM and this and that. But as far as the Arduino tool is concerned, the compiler, the libraries, it'll compile for it and build an executable and be able to upload it. It'll work. And then there might be some little tweaks. But that one right there seems to work. You could try another one. You could say, what about the ES32 Pico Kit or the Node 32S? Lots of them will still work, right? They're almost identical as far as the profiles and the software's all been loaded. Anyway, so I select this one right here. Good. And then it goes back. Okay. Don't worry about any of this stuff. This is just speed for doing things, but upload as fast as possible, which is this 921-600. The flash frequency, you set it. All these will default, but you can tweak them if you want. Don't mess with this QIO mode. That's the mode that you want to use. Leave this as default. There's other things you can do here. Core debug level, leave that at none. Now, the port, when you plug in the Arduino to your computer, which we're going to actually do. I'm going to unplug it and plug it in so you can kind of see what happens. It's going to create a serial port because there's a serial USB to serial chip on the Arduino. That's going to come up as a serial port, so you got to select which one, COM135. That'll give you a lot of trouble if you don't do that. So we got COM35. Okay, cool. We don't need to get the board info. That'll pull information from the board. Now, down here is some extra stuff. To make the any Arduino an Arduino, it kind of has a bootloader on it, and that bootloader helps the Arduino tool talk to it. We don't need to mess with that right now, and if we were to do that, we would have to program the bootloader, chicken and the egg problem, onto the board. How would we do that? Well, we could use one of these tools here. These are like big tools, like this. So this right here is like an Arduino. This just happens that this is not an Arduino. This is an AVAR programmer. So this is used to program, and I've got maybe 100 different programmers in my lab of all kinds of different things. So that's like a $50 programmer. That's one of these. It's this one here, the AVR ISP MK2. So if I wanted to burn a bootloader onto a chip that I made and I want to make it Arduino compatible so this tool could talk to it, first I'd have to use that, then get the bootloader on it, then I could talk to it with the tool. I know, crazy, huh? But you don't need to worry about that, and then that just burns the bootloader. So forget about that. So once you select the board from the boards manager and load in the ESP32 support, you scroll down, you'll be able to have all these different ESP32 things. Pick the board you have, but I want you to get the ESP Rover B or IB, okay? All right, now once you do that, now we can start grabbing things out of the examples and trying them. All right. Now what I want to do is I want to go look at this hardware and I want to plug this in and kind of show you what's going to happen here, all right? So let's go over to the bench and just take a look here, all right? Okay, so in front of me here, we have the module plugged into a solderless breadboard, all right? And then here's another one right here. I always get 2 or 3 of everything, so if I blow something up, I'm okay. So on the back here, you see it says Geekworm, and let me zoom in just a little bit for you. Help you out. There we go. Okay. So it says this KE32-Rover-C10, and then the whole idea is it's got 4 megabytes of PS RAM. There's another version with 8 megabytes. I think there might even be a 1 megabyte or a 2 megabyte version. But anyway, Geekworm is the manufacturer, and then the Express If module is right there, right? And you can see it says ESP32 Rover. It doesn't say the B on it, and that's just more or less the company gets sick of stamping every little version of everything on these metal cans, so they just kind of leave it off. And then, like I said, if I was going to build a computer or build a product, I would just have the module. I don't need all this stuff right here. Now, this one has this extra UFL connector, and then here's the antenna. Right there's the antenna right on the PCB, but then if you wanted to add an external antenna with more gain, boom, you can just plug it right in there. Then here is our, this is our serial UART, USB serial UART. There's our regulator to regulate the USB 5 volts to 3.3, couple switches, and then a couple LEDs, okay? And then I just like this so I can look at it and then like see what these I/O pins are as I'm messing with it, even though I can do it on the computer, all right? Okay, now, so what did I do here? So what I like to do is mount this thing on here so I can play with it and experiment and do whatever I want to do. All right. Now, problem is this thing is so wide. If you try to put it in just one of these solderless breadboards, you're going to have no room on either side to do anything. So you need a bigger one, or you need two, and then you straddle the power supplies rails. When you straddle it, then you have 3 on this side and 3 on this side. Okay. So what I did was, and this is all plugged in right now. So as a matter of fact, what I'm going to do is I'm going to unplug this because I want you to see what happens. I'll unplug it. And then under here, there's nothing magical. All I did was I looked at the module itself, all right? And I looked at it and I said, you know, where is ground? Where is ground? Where is, you know, the 5 volt? Where is this ground? Where's 3 volt? Where's all this? Then I labeled them like this, all right? And then this is 5 volt. So if you want to put 5 volt in, you could put it in there, and that's red. This is actually orange. And this is 3.3 volt. So now the board itself is going to generate the 3.3. When you put the USB in here, we get 5 volts roughly, right? 4.2, 4.5 to 5, 5.2. It regulates it down to 3.3, powers the module, and then outputs it right there. That output then goes, and then I use it to power this entire board. Now, I don't want to put a lot of things on here because it'll all be powered off USB, but as long as we don't go crazy, we have 500 milliamps to work with. Okay, then I looked at all the grounds on here, and then I connected them all to these ground. And then again, once you take the class, you're going to know that we have power rails here. We bypass capacitor, and we use it like a 10 microfarad, a 0.1, 10.1, 10.1, 10.1, and then just connect all the power rails up. So everything is 3.3 in ground, nice and clean. And then we can put this back in here like this, and we don't want to blow up anything. There we go. So that's it. All right, and then we'll just wiggle it in, wiggle, wiggle, wiggle. All right. Now we'll plug this in a second so you can see what happens again. So that's it. So now all of our projects we want to build, we basically just look at the back of this and we say, here's all these IOs. Now each one of these IOs can be a GPIO, but it could do PWM, it could do a UART, it could do Ethernet, it can do all kinds of crazy stuff, right? SPI, this and that. So it's all multiplexed. And the Arduino IDE knows about this. And so most things, like if you want to do something on one particular IO, you can tell that IO to be different things, and the libraries and so forth will help that happen. But knowing what is potential or possible on each pin really helps, and that's why having Kolbon's book or another reference that shows, you know, every one of these IOs, and it says this can also be I2C, this can also be this can also be that. That'll help you so you don't try and put something on a pin that it just physically can't do, right? Okay, so anyway, that's that. So what we're going to do is we're going to start off with just blinking an LED. We're just going to keep this super simple, all right? So what I'm going to do is I'm just going to pull this stuff out. I've got all my stuff here as usual. And again, if you just jump into this bonus lecture for fun, then you will learn that I like to keep things super clean so I don't go crazy. Now, we can wire things together with separate wires like this, you know, and I've got them all color-coded here, all my different colors, or we can do these, right? And you can get these off Amazon, all right? So just for fun here, I'll just pull a few of these out and split them up here. And I've got hundreds of these already split, but I like you to see the process, you know, so who cares? It doesn't cost that much money. All right, it's not going to put me into the poorhouse. All right, so we got some wires right there. So we can use those, and those go real quick. Why don't I like these, though? You guys know that. Because whenever we do anything like this is very noisy. I hate that, right? But if we're doing low speed stuff, it's not going to kill us, right? If we're doing high speed stuff, if we want to make something real, we take a nice piece of wire, we bend it at each end, boom, and maybe we go, here, and then maybe we need to go over here, right? And we keep it low to the board as possible for noise and so forth, right? But the stuff we're going to do right now is not that big of a deal. Okay, so now what we need to do is we want to do like the Blink demo and see how would you download this on here. The first thing I want to do is I want to show you what happens when we plug this in. So what I'm going to do is I'm going to plug this in and we're going to watch back on the computer what happens. All right, so here we go. I'm going to plug it in and then we're going to watch the computer. Here we go. Let's plug this bad boy in. All right, so now we're back here on the computer, and let me just close that tool. And then if we go look here, so nothing's happening. So what's happened here is that the USB to UART bridge that's on that device has already been installed in this computer, and then it just gave it back to me. All right, so check this out. If we go up to the device manager in Windows, you can do this in any operating system, and we look under COM ports, check it out. There it is right there. It's COM135. All right. So COM135. But if I were to take that other module and plug it in, it'll actually hook it up as another COM port. Let's do that for fun. All right, so let's go back over. All right, so we're back over here. So I'm just going to unplug this. And then what I'm going to do is I'm just going to get this other module. And I'm just going to I don't really want to mess with this too much. Maybe we can put it here. I'm just going to kind of put it here a little bit. And we're just going to plug it in here. Here we go. So this is a different module, so it's going to come up with a different ID. All right, so cool, that's going. Now, when we plug that one in, now the driver's already been installed because whatever USB to serial chip that's on there, which I believe is a Silicon Labs, it's definitely not an FTDI chip, the driver's already in my computer, so it doesn't reinstall the driver, but what it does do is go here. Now, both of them are coming up as the same COM port. That'll happen sometimes, okay? And that's okay. So the bottom line is when you do this, you are going to potentially have to sit for a minute while it installs the driver for that USB to serial. So this is all done as pure serial. There's no complicated program. It's just pure serial. That's why that bootloader is important for the Arduino, but it's already the Arduino toolchain support within for the ESP32 already knows how to talk ESP32, so you don't have to worry about doing any bootloader stuff. Okay, so we know it's on COM135, so let's go ahead and minimize that. Let's go back to the bench here and let's switch it back. All right, so now what I want to do is we're going to do this blinking LED demo, okay? And to do that, we need to blink an LED. Now there's two LEDs that are on the board, right here and right here. And they're at IO, I believe, 0 and 27. So first I'm going to do it there so you can see it. And then right after you get done with that, then we're going to use one of the IOs. Let me put this back here. We're going to use one of the other IOs here. So if I turn this over, like right here is here, and then of course over here is this bottom row. So we're going to use maybe one over here. And I think IO15, 1, 2, 3, 4, 5. IO15 is the 5th pin from here. So if I go here, 1, 2, 3, 4, 5, there's IO15, okay? So if I take that and I plug that in there, all right, let's get this nice and centered for you. And maybe you guys want to zoom in a little bit, help you out. Okay. Not too much because we won't be able to see. There we go. All right, so there's IO15, and then let's take an LED. Now, remember our LEDs? Usually the big side is the ground. Well, check it out. In this one, the big side is not the ground. It is the opposite. It's the anode. It's not the cathode. So this one is tricky. So the small side is cathode. All right, so there it is right there. We're good to go. Just to check that that works, let's take plus. So here's my +3 rail, and let me scoot this up just a little bit. There's my +3 rail, and 3.3 volts not going to blow this thing out, so good. All right, so this is grounded, so if I get a positive there, I'm going to be good to go. I'm just going to put a little current limiting resistor in here, 100 ohm, brown, black, brown, just because I like to do that, and it's good practice for you too. Okay. So there it is. So now we got this LED in here, but we don't need this one because we got two built on here, but those are boring to use. We want to build something, right? So let's see if we can get these LEDs to blink. So I'm going to kind of keep this right here. So we have this screen, and then we're going to work on the computer so that you can see what's happening in real time. All right, so let's go to the computer. Okay, so we're back here on the computer, and let's load our Arduino tool. Where did it go? Where did it go? There it is. Cool. Okay, so this is the blink, and this will work just like this. We need to define this and change what it is. So what I'm going to do is I've already made a version of this. So I'm going to say open recent, and I'm going to say blink ESP32, and I'm going to give you these. So here's my version of it. And what you will see is I haven't really done anything. And you know what? As a matter of fact, let's also help you guys out. Let's go to preferences again. There's a font in here. There it is. Let's make this size 16. And cool. So that helped. All right. So hopefully you can see that a little bit better. Okay. So if you look here, I said lead pin is 15. Now also let's go here. Here is that chart that shows what's going on here. So on these pins here, we see that on the board itself, remember I said IO27 and IO0 actually connected to those two onboard LEDs through, looks like, what, 2K resistors? So we can actually turn these LEDs on without using anything. So let's give that a try first, all right? So we're going to make lead pin, we're going to say, what is it, 27? So 27. All right, then we go to setup, and it says lead pin output, then serial begin. This, I'll show you what this does. This turns on the serial port, the same serial port we're going to use for programming. After this is programmed, we're going to use for communicating for debugging, real crude debugging. So it'll put it at 115K. Then we go down to our main loop, and in our main loop we say hello program. So that's going to print out on the serial terminal. At the same time, it's going to turn on this LED pin high, then delay for 10 milliseconds, then turn it on low and delay for 10 milliseconds. Okay, let's make that a little bit longer. Let's make it 100 milliseconds. Okay, cool. All right, so I'm going to save that. Now, let's learn what else do we have on this interface. Not much, people. Okay, so first let's go to Tools. We got our ESP32 selected. We got COM135 selected. That's correct. We know that. That's about all there is to it. Now, we got only a few buttons here. This is it. So what's this? Verify. Verify, and it comes up right here and says what it is. This means compile. This means compile and link and build, basically. This means compile, link, build, and upload. So it's going to upload it over the serial port. And then these three right here, this is just a new file, and then this one is open file, and this one's save file, which is, of all the things to put here, you know, they just put those few little things from the file menu. That's it. This is the entire Arduino experience, and it's basically C, all right, C++. All right, so let's go. So let's go ahead and let's just verify. Now, down here, I want to say, I can make this, yes, okay, I grab that. So I want you to see what goes on down here. All right, so let's go ahead, let's just compile it and link it. And compiling means converting it from C code, obviously, into machine code. And then linking means linking with any external libraries or references and then building a final executable. So it's compiling it right now, and it's compiling it with GCC or CLang. And I'm not sure, like I said, I don't use Arduino, you know, because it's a kind of a hobby technology, but the two compilers, GCC and CLang, CLang's been replacing everything. I prefer it. I believe now it kind of defaults to CLang, but I might use GCC. Not sure. Something to figure out if you're into it. Done compiling. Sketch uses 214,092 bytes, 16% of program storage. Maximum is 1.3 megabytes, it looks like, and then global variables, yada, 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 and all this. Okay, now remember, we're on the big ESP32. If we had been on a Arduino Uno, the little 32K, right, this right here, look at this, 214,000 bytes. Right? The little Arduino Uno only has 32K bytes. Of course, the program would be smaller because it wouldn't have all the complicated libraries that go along with the ESP32. All right? Okay, so that's done. So it worked. Great. So let's go ahead and upload it. So we'll go ahead and hit upload. And we'll be taking a look at the ESP32. So hopefully I'm doing a split screen kind of thing right now because I'm not going to go back to the bench. I'm going to sit here with you. And there's verbose modes also here, and you can see now we went into the programming thing, and the programmer is written in Python, and so it's called PyTool, I think, something like that. And then now let's take a look at this here. All right, let's back up. All right, so it's called ESP Tool, and it's this programmer. And then it says, hey, the chip is this, the revision code, it's saying what it's doing, blah, blah, blah. It's saying, hey, I'm going to 921 600 baud rate, and then auto-detected a flash size of 4 megabytes, compressed 8192 bytes to 47, because there's probably a bunch of zeros in it. And then it starts writing all these different memories that the ESP32 has. And then it's saying, you know, all the different percentages done, and then doing a verification. Remember, we had that in the preferences, do a verify, so it checks the memory. All right, and then lastly, we see this hard reset via RTS pin. So the programming interface on many of the Arduinos is done completely serially and through a USB to serial UART, like the FTDI chip or the Silicon Labs chip. And so to be able to control various things on these microcontrollers, they have to do it serially, just with, you know, a serial interface. So there's not much that you can do there. However, most serial interfaces have a modem interface. So they have DTR, data terminal ready, clear to send, request to send. They have a few extra pins. And then what they do is they take those pins from the USB to serial UART, and then kind of decided, hey, on the Arduinos, we'll use a couple of these pins, DTR and RTS, I believe, on some of the different Arduino hardware to be able to talk to the control pins on the microcontroller or on the module that control reset, boot, flash mode, etc., or what are called the strapping pins on there. And then therefore through the tool can control remotely to put the chip or the module into program mode or boot mode or this or that, so that we don't have to do it by pressing buttons. So anyway, that's what this hard reset is. All right, so anyway, you can see hopefully that the thing is blinking, and it's blinking on the correct LED. Let's go real quick and let's change this to, as a matter of fact, let's go ahead and add the other LED. All right, so there's two LEDs. One was at IO pin 0 and the other one was at IO pin 27. So we're just going to copy the code. All right, and we'll just call this 2. And this is what's cool about, and this is why people like Arduino so much. The funny thing is they think they're programming in processing, and they're not. They're programming in C. This is C. I hate to tell everybody. C++ actually. All right, and then here we're going to turn this pin high. We're going to turn the other one. Matter of fact, let's do opposite. So we'll do this low. And then here, we'll turn this one, make sure we got the right pins here. Of course, it's always, you know, I'm always in a rush, and time is always against us. So I'm always trying to go as fast as possible to give you as much cool stuff as quickly as possible. All right, I just Control-S and save that. Let's just go hit upload. And give it a minute here. And this is never a fast process under Arduino. If you use the GCC or CLang compiler with the IDF, the IoT development framework, it's definitely faster. All right, and now we did the hard reset, and there we go. And again, I have to look over there because you're seeing the edited version. So you can see it's blinking both LEDs just as it should. So how cool is that? Now, let's get that last LED, the one that we have the wire to, we know that's on IO pin 15. So let's go ahead and let's just undo what we just did. We'll just undo this code, and then let's make this 15, and we'll speed it up just a little bit. We'll make it 50. All right, and let's go ahead and upload. And I'll give you all these programs in a zip file. You know, they're almost identical to the examples. All right, again, we're compiling, then we'll do the upload. And then I'm just going to show you a couple more so you kind of get a feel for this. And you can go through all the different examples and see what works and what doesn't. You have to change these GPIOs and you have to understand what's available on each GPIO. But, you know, many of the basic ones work. And then you can see our LED is blinking. So we've talked to the pins on the board and an external pin. Let's do something else. So now I've also done a PWM. So let's go here. And as usual, it opens up another window. Let's close this. Okay, so here we go. Oh, that's interesting. The preferences are per file. Huh. All right. Let's just go there and hit OK. Is that 16? I guess it is 16, huh? Okay, yeah, there's a small font right there. All right, so what this one does is it uses the PWM software or API from the Arduino to talk to the PWM hardware on the ESP. Now, if you were to do real PWM and you were programming low-level embedded C, C++ code, I assure you it would take more than 2 lines of code. This is literally 2 lines of code. LED setup, LED attached pin, and then LED write. It's like too simple. That's why people like Arduino. All right, with this particular API that someone made, so I just found this little program, and it looks like you set the frequency. You can set it to kind of whatever to make the whole PWM. And remember, pulse width modulation is a bunch of different pulses. Each one of the pulses has a duty cycle. As you change the duty cycle, that one pulse gets averaged, and then we can control the brightness and generate an analog signal. So we can change its frequency. This LED channel, there's different LED channels. And I haven't looked at the API to see exactly how many and how these would map to the hardware, but it seems to work right now as is, so we're just going to leave that. LED pin 15, which is the pin it's already connected to. So then we say, okay, LED channel, the frequency and the resolution. This is just how much resolution we have to control the PWM. So in this case, it's 8-bit, and the hardware might have 16-bit PWM or 8-bit PWM. Right? So it's saying use the 8-bit so that gets mapped to the 8-bit hardware, even if it's 16-bit. And then this basically sets it up, couple setup things, attach the pin, and then you can always look at these inside of the documentation for this particular API, which is either made by Arduino or a third party. And then we just run a little for loop here. We go from 0 to 255, and then basically swipe the duty cycle so that we'll get this brightness kind of thing going on. And that's it, and put a little delay in there so we can see it. So I didn't really change anything other than changing this LED pin. Let's go ahead and go for it. So let's compile and upload, see what happens. And there's at least this little progress bar over here, although it does not show a percentage. I wish it did. It'd make the time seem like it goes a little bit faster, but I'm always trying to be entertaining. All right, and it's amazing how long it takes for such a little thing, right? And is this multi-threaded enough to do that at the same time? All right, and if you look at it, I've got to look at the camera. Yep, it's working. It's going up, right? And now, so now if we wanted to add to this, what if we wanted to go up and go down and kind of strobe? Well, we could do that. We could put, so this, so what happens here is we're going from 0 to 255, and then we have this loop function always gets called over and over and over. Even though it exits out here, it gets called again by the real C main, right? So what we can do is, and one thing you'll learn is I like brackets on the same column here. I like to do this, and we haven't really gotten into any programming. Now normally there's better ways to do this, but we're just going to do this like this. So we're going to say duty cycle equals 255 to duty cycle greater than, we're going to start at 255 and the duty cycle greater than or equal to 0, and then we're going to say duty cycle minus minus. That's it. And then we'll put the same delay here. And matter of fact, let's speed it up a little bit. We'll say 10. So it'll do an up and a down, and it'll exit out of the loop, right? Let's go ahead and give that a try. While it's compiling and doing all that, the program, of course, is still running. It hasn't told the processor to reset. It does it at the very end. All right, compiling, and now we're uploading with a little Pi tool, and now it's done doing the hard reset. And you see it goes up, and then it goes down. Up and down. There we go. Perfectly, just like we would expect it to. All right, so there's PWM. And then I've got one last program I want to do. So the whole idea of using a wireless module is to do wireless stuff, right? So let me show you this. Now there's lots of wireless demos inside of the ESP examples and so forth, but many of them don't work right and whatnot. There's a cool website, and this is called Random Nerd Tutorials, and this guy's got classes and ebooks and all that kind of stuff, specifically on ESP32 and other things. And he's got this example here where he made some code, and he shows it to you, and you can just copy it here and just copy and paste this entire thing into there, and he kind of shows you how to do this. So Random Nerd Tutorials, ESP32 Web Server, Arduino IDE, to kind of show you how you do this with the Arduino. So this is a good working little program. So what we need is, we need two LEDs, and what it's going to do is, from your phone or from your browser, you can control two LEDs remotely over Wi-Fi, which is really, really cool. So the first thing that we need to do is, we just need to hook up two LEDs to a couple of GPIOs. Now, his code, I took his code and modified it a little bit because it's a little bit hard-coded, and I cleaned it up a teeny tiny bit. And let me go here and show it to you. So we'll say open recent, and it is called not hello server, red green server. Okay, so here is the program, and if we look, it's not very long. All right, so this is an entire web server. How crazy is that? All right, so it'll respond to HTTP requests for the page and then print the page out. So I'm not going to go through how this works. You'll have to read this, but the one thing is, you're going to put your SSID and your password inside of SSID and password. You'll put that yours inside there. It's going to run this thing called web server on port 80, and then what we care about is I changed this because he was calling it, using the numbers 26 and 27 like pins, and so I just generalized and called it red LED and green LED, and then we can set these to any pins we want. So we're going to use pins 22 and 23. Here's the interesting thing. When you start messing around with Wi-Fi and Bluetooth, some of these pins on the ESP won't work right anymore, and you got to be careful. So as I tried a couple different pins, they didn't work, and how I would find that out is I would look at the data sheet and the ExpressIf documentation and make sure, oh, this pin can only do this, or this pin can only be input, and so forth. So anyway, pin 22 and pin 23, which are, if we look over here, let me move this, pin 22 and 23, right here. So they're on one of the rows, the two last pins right next to ground, and we'll look at that. We'll go over to the board and we'll actually put this together. Pin 22 and 23, we're just going to hook up to a red and green LED, and we'll put 22 to the red and 23 to the green. All right, again, we have our serial begin, and so we can see what's happening in the serial port, and then down here we have this while Wi-Fi status, so it's trying to connect. And again, we're talking about a few lines of code. Wi-Fi takes like 1,000 lines of code to get something going if you're doing low-level stuff. And then we go to the main loop here, and basically it checks if you're connected, and then it sends out the HTTP response and so forth, and the proper content headers and so forth. And then basically you've got two controls, and we can click these on the screen, and then as we do that, then it sends back to this little web server, which then controls the LEDs. Super cool. All right, so anyway, you should study this and figure out. Again, I'll put this inside of the materials. All right, so first thing let's do is let's go hook an LED, a red one to 22 and a green one to 23. So I'll meet you over on the bench. All right, so we're over here on the bench, and now we need to know where 22 and 23 is. So yeah, 22 and 23 are right there, the last two before ground. So 22 is the third one. All right, so all I'm going to do is I'm going to undo this, and this one's our red one. So I'm going to put this here, and that's going to go there. How easy is that? And that'll be our red one. And then let's get another 100 ohm. Here's another 100 ohm. Boom. Put that right there. We'll put this right here. Super simple. And then here's our green LED, and let's make sure which way this one works. So it works like that. So the ground is the ground the big one in this one, the cathode? Looking at it, yep, cathode is that one. The cathode is the big pedestal in this one. There, that is it. So we should be able to turn these on and off. Let's go back to the bench. All right, we're back here on the bench, and so now what I'm going to do is I'm going to put in my SSID and my password here. So close your eyes. Okay, so I put in my password and stuff, and now we're going to upload this. Now, in this example, we're going to look at the serial terminal, which has been running the entire time. We haven't, we didn't really look at it with the other ones, but it was actually running. I'm going to show you how to do that. I kind of forgot to show you that, but I'll show you in this. And that serial terminal is good. It was just printing hello programs or whatever, and it's a good way to be able to send information back and forth so that at least two serial terminal, and you could type in it too, and we could send information back to the ESP or any Arduino. All right, so now we're connecting and we're uploading, and this program, of course, is bigger, and it's not scrolling. All right, and it did the reset, so now it should be working. Okay, so check this out. So now, watch what happens here. So we go up to Tools, and then we say Serial Monitor. All right, so now this is monitoring. So the serial port 135 is now still connected to the PC, and now the programming hardware is not talking to it anymore in that mode. So we can look at it. All right, I'm going to go manually reset it. I'm going to press the reset button. All right, and then we see the ESP do some crazy stuff, and now here's our program running. So now it says Wi-Fi connected, IP address 192.168.1.203. So if we get a web browser or a phone and we connect to this IP address, we should see this little web server. All right, so what I'm going to do here is I'm going to type that in. All right, and then I'm going to open this back up. All right, and then I'm going to put it right there. Ready? There it is. Okay, so here it is right here, and now I'm going to press these buttons and let's see what happens. So it says red state is off and green state is off, and I'm looking at it and it looks like it. So I'm going to press on. The red one turned on, red one turned off, the green one turned on, green one turned off. So how crazy is that? So we basically just built a web app that's running. Here's the code for it right here. There it is. There's a little serial monitor. We can see that. And then, of course, here's what our little web interface looks like. And let me just make this small so we can kind of put everything on the screen at once. And there we go. So how cool is that? That is pretty cool as far as I'm concerned. And here's the program. Okay. So that is it. That is what I wanted to show you with the Arduino stuff, how to install the tool and get it all to work, and do a couple simple programs. And then, like I said, you just kind of go here to File and go to Examples, and then you can just try loading these different things. Many of them will work, some of them won't, and then there's specific ESP examples, more advanced, that have wireless and Bluetooth. You can play with those, load them in, and try and get them to work. All right, so that's it. Now, maybe in another video we'll do some other stuff, and then what I wanted to show you was this tool here. I'm going to close this real quick. I'm just going to give you a preview. And this is VS Code. Where'd it go? So Visual Studio Code is a kind of an editor that Microsoft made. And then it's very powerful. And then you can see here's that blinking LED program again, right? And then what you do is there's a piece of technology called Platform IO, and it's a plug-in to this. And then it allows us to program, well, you can make it program all kinds of things. Arduino is one of them, right? So it's got support for that, or other processors, all kinds of things. So this is a much more advanced tool than the Arduino tool, as you can see. So the next step will be, maybe we'll do in another video, we will install Visual Studio Code, then we will install the what's called Platform IO plugin, which is a whole series of libraries and technologies to be able to program all kinds of microcontrollers and boards. And then we'll see how do we build projects with Platform IO and use that to program the Arduino and do debugging and all kinds of crazy stuff. All right, so that's what we'll play with next, and we'll kind of see what this thing is, maybe in another bonus video. Like I said, I'd maybe like to do 3 videos with Arduino and kind of have some fun with this, all right? But this will be the next thing to kind of take it to the next level, all right? So I hope you guys like that, and sorry for the long video. You know how it is with me. I like to do these long videos to kind of go through all this stuff, all right? So I'll see you in the next one. Bye.